This is just an educational video. It's not an instructional video. Do not repeat anything in the video. If you do, use safety gear, gloves, fume hood, goggles, etc. I'm not responsible for anything you repeat in the video. Add 100 milliliters of sulfuric acid. I didn't do anything to it to clean it up. And I put 114 grams of table salt plus another 37 grams. Because I figure if I don't have enough, it's easier to add this sulfuric acid. And, you know, if I have a little bit in here, I can heat it up or whatever or anything. So here I'm going to start it up. Just want it to drip. Starting to build up a cloud in there. Uh-oh, it's starting to bubble. You can see that. That's it. I'm just going to leave it go. The line erased that I had on here, but I remember where it was about. So once it fills up to that line, it's done. That's not bubbling over here yet, but given time it will. Right now it's just making it to here. I don't smell anything. Anyways, that's it. That's the whole setup. All you do is wait now until it fills up. I can see where it's at. It's got a while to go, that's for sure. So this is somewhat boring. I mean, we're just sitting here. So I guess I'll come back at the end of the experiment, because this is it. I'm just basically going to sit here and make sure that there's no suckback. I got to make sure that it drips. If it stops dripping, it'll stop making the HCl. If it does that, the HCl that's in the apparatus will get absorbed little by little into the water, and eventually will cause a vacuum over here on this side, and you will get a suckback, you know. But we got our traps here, just in case. This can't be sucked back, so I put a little bit in there. Whoa. Well, I just realized something. Look at this. This was filled up all the way to here. What happened? What's going on here? Is it getting sucked up the tube? What the heck? Well, I have to make some more. Turn it up faster. Oh, put it on there backwards, I bet. Yep. Crap. Son of them. Okay, well, I see what was happening there. You can see now I lost half of my whatever. But it just got sucked back into the next thing there, that graduated cylinder back here. Right here with the towel in it. I had this on backwards, and that's this here. And you can see what happened. So I have everything back to the whatever. That's why it wasn't bubbling into there. Because, oh, there it goes. See how it's bubbling now? It's like a shoot above. I don't care how good it absorbs it. It's got to bubble something. It's got to push some air through it, right? All right. So at least we see we got everything working. Everything's bubbling. That's bubbling over here. This is bubbling over here. I got a good drip rate. I don't know if you can see this, but I did get right here the first whatever. It did suck back from here just a little bit. But it will absorb all this. There's just too much gas passing over it. It will become saturated. Now keep in mind that it's not going to go up as high because of that. But when I put them together, I'll do a density test. So far, I don't smell any HCl or anything like that. Even though it doesn't have as much to bubble through here, all that water and sodium hydroxide went into the next vessel, so it has to bubble through it anyway. It just has to bubble through the next vessel. Now you can see the drip rate. There's a drip rate. It's actually too slow. So I'm going to turn that up, and I'm going to turn this film off, and I'll get back to you when I dripped all that in there. Now about halfway through, I turned up the drip rate. Right now, see, I got it going pretty good. Drip, 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 drip. There's only a little bit left. Because, you know, it takes time. A lot of that solid in there, right down here, that's not salt anymore. I mean, it's not table salt. It's, what is it, sodium hydrogen sulfate. Sodium bisulfate. So it needs time for the, you know, the acid to come in contact with some table salt. So you want to turn it up. When it gets down to pretty much where it's at, I'm about ready to just dump it all on at once, you know what I mean, like stream it in. Because otherwise what will happen is you'll get a suckback effect because you're not making it fast enough. Alright, so what I'm going to do is I'm going to keep heating this pot over here. It's done. It's out almost. See how it's only a little bit left. So I didn't do a density test on this. This was that one that was just filtering. You know, it was used to help scrub the HCl before it got out of the apparatus. You can see I had it in the freezer, and there's ice in it now. You can see that. But anyways, so you know it's less than 10%, or I think it'd have to be at least 10% for you to have it start freezing. Oh, and also this right here, that's like 250 milliliters of stuff. I mean, it was acidic enough to give a 1. Actually, probably more than 1. It's darker than it, so maybe it's less than, you know, it's even more acidic than 1. I don't know. This stuff, what I'm going to do is, I don't know if you can see on film or not. Let me there's a whole bunch of ice in there. What I'm doing is I'm taking it out every once in a while so it doesn't just get ice on the sides and break the glass. And once it ices up enough where I'm afraid it's going to crack my glass, I'll take it out. I will filter all that ice out of there, and then I'll have, it's not going to be concentrated, but it's going to be more concentrated than it was, that's for sure. This has been in the icebox forever. There's nothing freezing up. It's totally clear. I didn't make the 100 milliliters. It should have really been up to here, but that's because I had that suck pack. I bought that new scrubber thing and put it on backwards. So anyway, there was a little bit of suck back. But I did do a density test. This is density of the difference, like 10% hydrochloric acid, 20% hydrochloric acid. This is what you would get at the store, 32.5%. So your density would be 1.159. You can do it in grams per milliliter, kilograms per liter, whatever you want to do. But anyways, 36% is where you start getting, you're considered, maybe even 34% you're considered. I consider 35 or above to be really concentrated. Here's 36 is 1.179. 38% is 1.189. And let's hear what I got. I got about a 1.15, so about 30%, say. But I want you to remember that, remember I had a line I was having around here? That line, by putting this in the freezer beforehand to cool it down, which, by the way, I did cool it down so that there was ice all in it. You know what I mean? But anyways, that line, because of all the condensation on the outside, disappeared. And not only that, because of that suck back, some of this came out and got sucked back into the previous round bottom flask. And so I didn't know exactly when to stop. Now, if I didn't connect that one scrubber up backwards, there would be no suck back. I would have had my line there, and I would have known exactly when to stop. Okay, and I would have got, if not 38%, very close to it. I would have got 36 or 38%. Okay, but because of the suck back, losing the line, I had no clue as to when to stop or whatever. So I got about, say, 30%. But like I said, I could have got, could have kept going. But I definitely needed to heat it up. You know what I mean? That 1.74 times a mole, I should have definitely put maybe two times a mole instead of 1.74 times. Or more, so I could heat, because you saw at the end there I was heating it up with a what do you call it, a heat gun. But I didn't take it all the way to completion because I figured, well, it's got to be concentrated. Well, it was close. Going from 0% to 30%, that's a pretty good, even 30% is, almost considered concentrated. Like 38%, that's pretty much the highest you're going to get. I don't know from experience, but I think once you get to 38%, it's tough to keep it in there with, as much as you pump in, stuff will be pumped out. Trying to get above 40 is almost impossible, I think. Anyways, you all have a great day, and always remember, science is great.